Right, let's get started with today's session, which follows neatly on from the last couple of weeks in the way that you'll have come to expect by now. We will be pursuing similar kinds of examples, and what we're going to be doing is focusing on, I kind of said a couple of weeks ago, we more or less force you to focus on quantitative rather than qualitative data in this course. And once you've decided whether you're going to go quantitative or qualitative, which I've forced you to go in a certain direction, you then have to decide, well, what kind of data are we going to collect? And we talked in a previous session about you needing to set the context for data collection, as in where do you want to do, what do you want to be your units of analysis? Do you want to do it at the individual level, aggregate level? Do you want to do it over time? How do you want to do it over time, etc.? Of the types of quantitative data, and this is going to overlap with that stuff about individual versus aggregate level in a way that I'll talk about shortly, there is the experimental approach. And we saw that there were, in week 6, that there were ways of doing certain things experimentally, but it was going to be very difficult to do certain other things experimentally. It's very difficult, for example, to do an experiment to see whether living in a democracy, other things remaining the same, makes you happier. Because you can't take two countries that are at a similar kind of stage and say, look to one of the countries, do you mind just holding this process of democratisation you got underway, because we kind of want to see whether you get unhappier than the country that we're going to let democratise. It's not feasible. It's not even ethical. And so most of the time we are relying on observational data, as in we just have to observe the world and, by controlling for enough other things, create as close as we can to the kind of lab environment that the scientists take for granted but we can only aspire to. If you are going to use observational data, there are, broadly speaking, two types on which you will rely. And today will be about those two types. Now, I mentioned that this is kind of related to the issue of level of analysis, and that is my attempt in mathematical operators to indicate what I mean by this. As in, there is a clear similarity between what I'm going to talk to today, what I'm going to talk about today, and the individual aggregate level of analysis thing, but they are not the same thing. That's what the second little signal means. What do I mean by that? Well, first of all, let's focus on level of analysis. If you have a model like this, you can test that at either the individual level or the aggregate level. The exam will feature things like this, where you might be presented with a model like that, or maybe just an XY relationship, and you will be asked, well, what would it mean to test it at the individual level? Or if you did test it at the individual level, what would be the key variables? And if you were testing this model at the individual level, what you would be suggesting is that an individual person's happiness depends on the one hand, how much money he or she has, and on the other hand, how democratic he or she sees that country as being in. If you were going to keep it an individual level model, then we're talking about individual characteristics, individual income, and individual perceptions of the democracy around. Because it's no good living in a democracy if you think it's a dictatorship, we would assume, for happiness purposes. That's the individual approach. Equally, you could say, well, I'm not actually that interested in what individuals think. What I want to know is, are countries happier on average if they are richer in terms of GDP per capita, and if they are more democratic in terms of some kind of a classification of how democratic a country can be? Looked briefly at that last week. We'll look in more detail at it today, what it means to measure democracy. So, it's important that you have in your mind, important for your greater good, but perhaps more pressingly for the exam, that you understand that research questions can often be addressed at the individual level, where we're looking to see how individuals' perceptions and attitudes and characteristics drive individual attitudes or happinesses, and the aggregate level when you're taking all of this on the country level. If countries are this, if countries are that, are countries more the other? Now, this all relates to the type of data as in the official statistics versus survey data distinction. Because official statistics, as we will go on to see, are tied very closely to the aggregate level. If you have official statistics on a country's money, for example, that is GDP. You don't, when you look up a country's GDP, get to find out what the GDP of a particular person in that country is, let alone to see whether that person is happier than somebody else. All you get to see is how rich is that country on average. And if you get a democracy score for a country, it's not going to break it down. It's not going to say it's more democratic for this person, or it's very democratic for the president, but not so democratic for this person who lives here. It's just going to give you a score. These are aggregate level data. Official statistics are at the aggregate level. However, the reason why these things are not exactly the same, strange noise. The reason why these things are not exactly the same, we can't just say, oh, official statistics equals aggregate and survey equals individual. Because if you think about it, you could test the model at the aggregate level, but based on survey data. Because what you would do is you get a survey and you'd find out the average income, and you do a survey and you'd find out how democratic people see the country as on average, and you would see how happy people were on average. So survey data, although they're obviously collected from individuals, can be used to create aggregates because you just average it. Average happiness in that survey in Britain was 7.2. Right, now we can go and find the average in France and find out whether the British are happier than the French because part of it's qualified for the World Cup, or less happy because the food's worse, or whatever it might be. And so survey data have this characteristic. We can compare across individuals, or we can aggregate them to compare across countries. And actually the whole thing gets even messier because it's not that difficult to think of measures, an unprecedented outbreak of lateness. And on this occasion, all the latecomers are caught on camera for posterity. So it's not just a... Any road. If we wanted to test this model at the aggregate level, you wouldn't actually, if you think about it, need a survey. Because we get GDP statistics, governments obligingly collect them, as we'll see. We can work out democracy statistics, and you don't need a survey to do that, as Van Hanen will shortly show us. And even happiness. The obvious way, I think, to find out about happiness is via a survey, but you could, for example, look at suicide rates as a proxy for happiness. The higher the suicide rate in a country, presumably the less happy it is. Number of prescription, not sure what's the general term for things like Prozac, uppers or whatever. Some kind of, you can see how often medical people prescribe mood-lifting drugs, and you could use that as a proxy for happiness. So pretty much whatever you're going to do, you can either use survey data or you can use official statistics, whether you're going to do it at the individual level or the aggregate level. The only key point is this one. Well, they're all key points, but the keyest point is this one. You cannot use aggregate level official statistics to test individual level models, individual level hypotheses. Because if you do that, as we'll see, as we've seen before, and we'll see again, you risk the ecological fallacy. So, what do I mean by the distinction between official statistics and surveys? Most of you will already know the answer to this question, but for the sake of contractual obligation, I will go through it. And it's well illustrated by the distinction between two measures of democracy mentioned last time as well. Van Hanen, the Finnish political scientist, not Dutch, as I wrongly said last year, and somebody sent me a rude email complaining. That person then got 38 on the exam though, which cheered me up a bit. He says that you measure democracy via two official statistics. And official statistics, remember, come in a range of forms. They basically mean, as we'll go on to see, what the government collects statistics-wise for the whole country, and election statistics are official statistics. And he says you find out what the largest party got in the election, you find out the turnout in the election, and then you, using that not particularly complicated formula, you get a score for democracy out of 100 for that country. It's an official statistics-based measure of democracy. Now, we can have our qualms about how well Van Hunen is measuring democracy, and I mentioned a few of those last time, but for the moment, the key point is this is based on official statistics, and in that sense, there's nothing subjective about this. Nobody's made a judgment, or at least the only judgment was how to do the measuring in the first place. Once you agree with Van Hunen that that formula is the way to measure democracy, then it's just a case of counting. In contrast, also mentioned last time, Freedom House have a political rights index. They never really call this a measure of democracy, but everybody else does, and so will I. And they get people who live in a country, are experts on a country, political experts, to rate that country on a range of criteria. I'm not sure if it's more, I think it's even more than 10 criteria these days. Or maybe 10 criteria for the political rights index, and then 15 criteria for the human rights index, and so on and so on. And then when all of the data are in, they somehow translate this into a 7-point scale for countries. And this is actually a survey. It's not the most orthodox form of survey in the sense that it's not going to a representative sample of the population of these countries. They don't ask the people how democratic they think it is, presumably on the suspicion that if you send this to North Korea, people will either believe it's democratic there or be too scared to say that they don't believe that, in which case you wouldn't get much valid data. So they go to experts, but nonetheless it's a survey because they're asking people what they think of things on typical survey type scales. And we'll talk much more about the pros and cons of surveys at a later point. For the moment, let's focus on official statistics. This is a relatively boring bit, but it is, like all the boring bits, necessary and in some sense good for you. So, the big bonus for us is that governments, for their own benefit, not for ours, but a byproduct of government activity is statistics. And many of our research questions involve exactly the kind of variables that states are interested in, like GDP, for example, or turnout in elections. And because this is something that states do automatically, there's a huge range of these things. It's not that we're confined to the economic sphere or to the health sphere or whatever. They're collected whenever governments do anything, and governments do an increasing amount these days, official statistics get collected. Mostly it's kind of as a matter of course, the usual government activity. Occasionally though, governments go in for some large-scale data collection of their own. And the census is the paradigm example of this, which is kind of an uneasy somewhere between official statistics and surveys, but probably counts better as official statistics. So occasionally governments do ad hoc data collection, but for the most part it just happens anyway. And because it happens anyway, and it's kind of public stuff, it's usually made freely, cheaply and conveniently available to us. And as we'll go on to see, the reliability of these data, and you need to remember that reliability doesn't just mean, is this generally any good? Reliability has a specific meaning, which is if you somehow hypothetically measured that immediately again, or if in some parallel world you measured exactly the same thing again, would you get the same result? And the answer to that is usually roughly yes, as we will see. So, the first advantage I've already talked about. They're cheap, because we don't have to do them, basically. It's the ideal form of data collection, the ideal form of any kind of work is one that you don't have to do yourself, and government data collection falls into exactly that category. It's also very good for comparison, because governments, although whoever's running them changes, the civil servants who do this kind of thing don't change much. And they do the same thing year after year after year after year. So comparisons across time are very straightforward with official statistics. Surveys, it's expensive to keep doing the same thing, and if you want to keep doing the same thing with the same people, it becomes very expensive, and then they unhelpfully die and all that kind of stuff. Whereas with government data collection, they just keep doing it, and we get year after year. And if you want to know the relationship between inflation and support for the government, you can do this on a quarterly basis, because opinion polls go back for God knows how long, and inflation statistics go back to 18-something, or maybe even earlier in some countries. They're also pretty good across space, because very often governments collect similar kind of data the world over. or if not the world over, maybe the OECD over, or other groups. Supranational organisations often tell governments that are within their umbrella to collect certain types of data in the same way, which means we can compare. And the breadth of these across areas of government policy, the scope of them, as we'll see in terms of the fact they often do the whole population rather than a sample, means that, if you wanted to know, for example, the relationship between GDP and happiness, and governments just in this age of austerity stopped collecting GDP statistics, forget about it. No researcher has the resources to collect GDP statistics. You could maybe do some sort of a sample in what you thought was a representative area and watch economic activity and hope that that was pretty representative of the country. But I'm not sure how good an option it would be. If we want to know about many things, this is all we've got. The reliability is very high for two reasons. Number one, governments have done a lot of this. They get pretty practiced at collecting data. And reliability, remember, is the absence of random error. And random error often comes with not really knowing what you're doing in whatever sense that might mean. If governments have an established infrastructure for collecting data on unemployment, let's say, it becomes a bit of a matter of routine without the random error that you get from well, literally errors. But there's another reason for high reliability, perhaps an even more important reason, which is that governments don't do a lot of sampling. When governments collect data on, for example, the number of people who are unemployed, they don't take a random sample of 1,000 people, ask them whether they're unemployed, and then extrapolate it to the population. As we'll see, they kind of do that as well, but they also collect statistics for the whole country. And if you think about it, this is likely to eliminate at least some unreliability. Because sampling, as we will see in, I can promise you, tedious detail next week, inevitably involves some unreliability. If you do an opinion poll, let's suppose that the truth of the matter is that anybody got a political party that's close to their heart that they want to use for this example? Let's do the British Conservatives. And let's assume that they are currently, this is an optimistic reading, but on 40%. In reality, in Britain, 40% of those who would vote in an election, let's say, would vote for the Conservatives. That's the truth in the population. Opinion pollsters don't have the money to survey the population. They survey a sample of about 1,000 people. And the single most likely result that they will get is 40, if that's the truth and they're sampling properly. But we know that, well, they won't always get 40, because if you do a sample of 1,000 people from 50-odd million, it's not going to be perfect. So it's quite likely that they'll get 38, and it's not that unlikely that they'll get 43. It's pretty unlikely, with a reasonably sized sample, that they'd get something like 34, and it's incredibly unlikely that they'd get something like 3. And what you get is a nice curve that looks something like that, distributed around the truth. And this, insofar as you get anything other than 40, that is random error. It's random because it could just as well be above or below, but that's just what it's like when you sample. You get random error. If you toss a coin 1,000 times, you won't get 500 heads or 500 tails. That's the single likeliest thing you'll get, but you'll probably get 491 of one, or 512, or 536, or something like that. And you get exactly the same kind of shape. And it's not that the coin's biased, so it's not invalidity, it's just random error, unreliability. The government, however, doesn't do any of this. The government, if it wants to know what proportion of people, let's say, are doing a certain job, let's say it wants to know what proportion of people are in non-manual, unskilled labour as it defines, and let's say the truth is 40, what it will get is 40, because it's not doing a sample, it's doing everyone. Now, there probably will be a bit of random error because it takes a little bit of time to collect this, and maybe 1 or 2 people will die, or 1 or 2 people won't be available to be asked, or whatever it might be. But the point is, when you try to measure the population rather than a sample, you eliminate most of the random error that inevitably comes with sampling, as we'll see next time. So that's reliability. Pretty good, a tick for official statistics on reliability. That is, would you tend to get the same thing if you measured it again, or is the measure polluted by random error? When it comes to validity, which is the question of, are we measuring what we're supposed to measure, it's a bit more dubious. And there are 2 stages to this if you think about it, because the first thing is the validity question for the government. The government wants to measure something when it collects official statistics. But then there's the question of, is what the government wants to measure what we want to measure? If we are going to use official statistics as the measure of something, we need to know not only what they were trying to measure, but whether what they were trying to measure is what we want. Because ultimately, for us, the validity question is, does this measure what we want to measure? So, to return to Van Hanen's example, the answer to the first question, as is fairly often the case, is pretty much yes. There will be errors in government turnout statistics. In some countries, those errors will be fairly substantial, as for example in the Russian election, where some neighbourhoods had a turnout of 103% and things like that. And there will tend to be systematic biases where, for example, the electoral register, or whatever is the kind of the frame from which you take voters, if that's incomplete because some people are not on it, then the turnout that you record will be artificially high, because you'll only be recording the turnout of those people who were registered, not the turnout of the potential electorate. So there are some questions about that, but for the most part, we can probably guess that government's turnout statistics, especially in reasonably free and fair elections, are pretty much a good measure of turnout. Whether they are a great measure, for example, of participation, let's say you wanted to do a study of the relationship between education and political participation, and you just use turnout as a measure of participation, somebody could say, well, that's not really a very valid measure of participation because it's the most low effort, the most norm-heavy type of participation that there is. And you should have been measuring things like signing petitions or boycotting products or taking part in demonstrations. And if somebody like Van Hanen comes up and says, oh, I'm going to use turnout to measure democracy, to me how democratic a country is how high the turnout is, you might very reasonably say, well, I'm not sure it actually is, Professor Van Hanen, because there's all sorts of reasons why turnout might be lower that have nothing to do with being undemocratic, like people basically being fairly happy and not bothering, or it raining. And rain erodes turnout, but not, we presume, democracy. So, for the most part, we would guess that governments usually measure roughly what they set out to measure. But the second question, much less likely to get a clear yes. Even on question 1, however, there is a major caveat which we need to consider. And that caveat is this idea of how much you are covering of the phenomenon that you want to look at. And for this we can take 2 parallel examples. In the case of, in Britain, and there will be similar examples elsewhere, but I'll stick with the British examples that I tend to know better, the government wants to know about the level of unemployment and it wants to know about the level of crime. And in both cases it has official statistics sources. There are the statistics on unemployment, which measure economic activity, and they measure in particular the number of people who are claiming unemployment benefit. And there was a huge hoo-ha in the 1980s about them switching the definition of unemployed from not doing anything to actively seeking work and therefore being able to claim benefit. And when it comes to crime, well, they have the official records of crime. When a crime happens, somebody's supposed to report it to the police and then they write it down, and they're always complaining about spending all their time in the back room filling in these forms instead of getting out there and and hitting criminals like they should be doing. And when all of the smoke is cleared, we have the official statistics on crime. But in both cases, as well as in parallel to the official statistics, there are these big surveys, the Labour Force Survey and the British Crime Survey. And the reason for those is that people had their doubts about the coverage of the official statistics. There may, for example, be people who are not claiming unemployment benefit who are nonetheless unemployed. And there may well be, in fact we know for damn sure that there are, a lot of crimes that go unreported for all sorts of reasons, usually because people don't think there's much point. And certainly when you do these surveys, and you say, well, we did a survey of 10,000 people, and we got this many crimes, and then you have to do that thing where you say, right, so if we got this many crimes in 10,000 people, among 50 million people, there must be this many crimes. And people might reasonably say, well, how are you that confident? You can just multiply by a lot and get up to the population figure. But as long as you're willing to take that sampling thing on trust, and we'll talk way more about that later today and next week, then you reach the conclusion, as many people did, that the survey estimates of both crime and unemployment are a lot larger than the official statistics element. And they coined this phrase, the black number, which was the gap between the two. That is, the crimes, for example, that apparently took place according to the survey, but were not reported. Or the unemployed people who are unemployed according to the survey, but are not showing up on the unemployment statistics. Remember the measurement equation? It's nice and simple. What we measure, what we get, is equal to the truth plus some error. And this error term could be negative, so this could actually be x equals t minus e, if, for example, there are 200,000 more crimes than show up in the official statistics, then the official statistics will be the truth minus 200,000. Now, as also mentioned when introducing this formula, the big trouble for us is we don't actually know what the truth is. We've got our official statistics, we've got our survey. They disagree. There's no way that we can go out there and do some sort of additional research that would resolve this issue forever, because it's just too, there's just too much out there. If the government's put all of its money into collecting crime statistics and it's still getting it wrong, there's no hope of us doing anything other than estimating which is closer to the truth. And most people who work in this area have come to the conclusion that surveys are closer to measuring the truth, especially in the case of crime, where the incentives for not reporting are so great, but also in the case of unemployment. But whether it's the case that the survey is almost spot on and the official statistics are way out, or maybe the truth is slightly closer to the survey but still actually quite a long way from both, because the survey way overestimates and the official statistics way underestimate, very difficult to say. And as I'll come on to shortly, there are reasons to doubt the survey statistics as well. Now, why are we sceptical? I mentioned that I was sceptical about the answer of whether governments are measuring what we want to measure, and there are various reasons for that scepticism. One of which we'll come on to is the kind of obvious one about, oh, the bastard government's lying to us. But that is by no means the most important one, and that is a central theme from this lecture on official statistics, that the paranoia approach is not really getting the key reasons why official statistics have their limitations for us. One reason, a major reason for doubting the usefulness of official statistics for our purposes is, remembering back to the idea of measurement, we want to measure concepts. We, to put it simply, are cleverer than the government. We're operating at an intellectual plane above them. We don't want to measure stuff, things happening. We want to measure complex intellectual concepts, whereas governments want to measure behaviour. And behaviour is usually a clumsy kind of proxy or surrogate or near equivalent for a fancy concept. Democracy is a high-flown concept about which political theorists have argued for millennia. Turnout is a boring number based on people doing things. And also, as noted when talking about measurement, the definitions of these things are a matter of disagreement. And governments may have different perspectives from each other and may have different perspectives from us. So even if they're trying to measure something similar to us, and we can talk about unemployment and crime, but we can also talk about turnout. I mean, from the government's point of view, what they're fundamentally interested in is how many people of those who were on the electoral register, how many voted. But we might be interested in, well, but how many people who are actually out there voted? Because that is a clearer measure of the kind of thing that we're more likely to be getting at. It's only when we come to the third reason that we're on to the bastard government's lying to us. And this actually occupies quite a lot of the textbooks on official statistics, but needn't detain us for as long, for reasons that will become clear. I don't think it's necessary to dwell on that much on the reasons why governments have incentives to manipulate official statistics. And these incentives, kind of starting at the bottom, there are the obvious ones like it's easier to get re-elected if the statistics look good. But there are also other less sinister reasons. If you think about measurement, what you measure depends on the way you see concepts. It's not difficult to imagine that governments with different ideological commitments will come at this thing from a different angle. Hence the argument about the definition of unemployment. Left-wing governments in the 1970s thought that unemployment was people who were not employed. Right-wing governments in the 1980s thought, well, no, I'm not prepared to call somebody unemployed just because they're not doing something. In order to be unemployed, you have to be actively seeking to be employed and available for work and claiming benefits. That's an ideological debate, not a measurement debate, really. And very often governments face financial constraints in what they collect statistics-wise. It's extremely expensive collecting official statistics, way more expensive than we can ever afford to do as social science academics, but often too expensive even for governments. In an ideal world, the government would have a census every 10 minutes, but it's way too expensive. And as a result, the census that they do every 10 years very quickly becomes seriously outdated. But what's the solution? Only a lot more money than is available. And there are various forms of manipulation, some of which are more malevolent and evil than others. And again, some of this stuff, you will recognise it from news stories and you'll recognise it as almost kind of laughably obvious manipulation. But most of it actually turns out to be reasonably kind of sane. The blatant and deliberate manipulations of official statistics are probably the exception rather than the rule. There was one during the previous government in Britain in which a promise to balance the budget over the economic cycle was refined when somebody stood up in Parliament and said, actually we've decided the economic cycle now finishes in 2000 and whatever, rather than 2000 and whenever that everybody had thought before. So blatant, nobody was particularly fooled, and I doubt it had much positive effect. But they're the exception. Most of these things actually make a fair bit of sense. Seasonally adjusted is a phrase that makes some people go, oh, they're cheating us. Where in fact it makes complete sense in the case of, for example, unemployment, to adjust, especially in countries that rely heavily on the tourism industry. Any political party that said, disaster, unemployment has rocketed since over September and October, when anybody would say, well, of course it has, because it's always higher in the winter than in the summer, because there are a lot more jobs in this nice, warm, coastal country, I'm not referring to Britain anymore, obviously, than there are in the winter. And when it comes to crimes, it makes sense, especially to a liberal like me, to when a policeman comes across somebody committing a minor crime, to say, no, don't do that again, rather than go through all the rigmarole of arresting them. But that means the crime statistics will go down. Now, you might disagree with me about whether that's the way forward, but the point is that the police behaviour will affect the statistics that you report without this necessarily being manipulation of an evil kind. It's just a different view about how you should behave. So when people are bickering all the time about hospitals and their targets, an obsession with getting waiting lists down, it's easy to lose sight of the fact that actually it's kind of a good thing to get waiting lists down, because waiting's bad and so is dying, and encouraging hospitals to treat people quicker may be the way forward. And turnout tends to fall whenever countries, most countries have got down to 18 now and seem to be stopping there, but the release of the franchise, as you'll doubtless be aware, was pretty grudging and slow in many countries. It took them a long time to give it to the vote to middle-class men, and then eventually to working-class men, but it tended to be people over 30, and then gradually they gave it to men who were under 30, and then, shock horror, they deigned to give it to women eventually, when all the categories of men had been catered for. And pretty much all of the lowering of the voting ages resulted in lower turnout, because you lot don't vote enough. But nobody would say, they're fiddling the statistics. It's just a change in behaviour. And the key thing really when using official statistics is not to be on the lookout in an X-Files kind of way for manipulation. It's just to be aware when any changes in the calculation happened and to factor them into your analysis. So that's my main message. Not because I think that people should be naive when using official statistics. You shouldn't. And especially in certain countries, but in any country, governments do have the incentives to manipulate, and they will if they think they can get away with it. But I think that by far the bigger issues with official statistics are they measuring what we want them to measure? Are they good measures of our concepts? Are they adequate in terms of coverage? And do any changes in the calculation disrupt the relationships that we're really interested in, which is the relationship between this official statistic X and some other Y? Anybody got any questions about, I never normally say this, but with the cameras for the sake of completeness. Does anybody have any questions on what's gone on so far? Good. Other big issues, other deficiencies of official statistics for our purposes. Bearing in mind, as I said at the start, we're kind of using them a lot of the time anyway. There's not often we can choose, so it's more a case of being aware of the limitations. And you'll recognise the first two of those questions because they've been dealt with in previous sessions. And you can answer these questions with official statistics. We know, for example, that the answer to the first question was yes. And we know that the answer to the second question is yes. We need to note, though, that we cannot go from the yes to question one to say that unemployed people, unemployed individuals, were more likely to vote for that party. And we cannot say that within a country, the richer people will be happier than the poorer people. These are aggregate level relationships. And official statistics can answer them because official statistics give us the electoral statistics for that German district and that German's the unemployment and the election statistics for a given German district. And we get the GDP for a country and the average happiness from a survey for the country. But we don't get the individual level data necessary to answer the questions like, was it unemployed people who voted for them, and is it rich people who are happier than poor people? If we go from an answer to these questions here to an answer about the individual level, we're risking the ecological fallacy. Well, we're kind of committing the ecological fallacy and risking that it'll be kind of real. And the last one is designed to kind of give you a clearer idea of how obvious that is. It is clear from international relations that the answer to that last question is yes. In fact, some people would say not just less likely, but virtually guaranteed not to. But you could not conclude from that individuals who are more democratic in their values are less likely to fight other individuals who are democratic in their values. We have no idea. Might be true, It almost sounds as if it probably is. But you can't go from some conclusion about a country to conclusions about individuals. And because official statistics are inevitably, as said at the very outset, at the aggregate level, we cannot use them to draw conclusions about the individual level. And this is a fundamental limitation of official statistics. If your research question is about the individual level, as in are people who are this more likely to be that, you can't use official statistics, because official statistics are aggregate and you cannot infer individual level relationships from the aggregate level. When I talk about individual and aggregate level, which I do frequently, as you'll have noticed, I discern a kind of sheen of semi-comprehension on people's faces. And short of my solution to that will be to keep talking about it in as clear a way as I can, and I will encourage the class teachers to do the same. If you find that every time I mention aggregate and individual level, you go, oh no, he's back to that again, and I didn't understand it the first, second, third, fourth, or fifth, sixth, or seventh time, you really do need to ask me to explain it yet again in yet another way, or to read a textbook about it, or to talk to your class teacher about it, or to look it up on Wikipedia, or whatever else, because it's absolutely central, both to your conceptual understanding of GV 200 and to the exam. Now, a second issue with official statistics and their aggregate level nature that will remind you of an earlier session, hopefully, and that is a significant limitation, refers to the issue of causality. Because if you'll remember, we have a lot of occasions where we have a relationship between X and Y. And with nothing else, if all we see is that there's a statistical relationship between them, we would be forced to call that a correlation. It would be very difficult for us to say, definitely it's that causes Y. Now, sometimes we have good theoretical reason to suppose that it's X that causes Y rather than the other way round, but we'd still ideally want to know, well, how does that work? What, for example, is the key or are the key intervening variables through which X influences Y? That's the kind of causal chain that we want to trace, if you do trace a chain. And what this comes down to is if you think of those four questions again, but this time stick a Y at the beginning, you get to questions that are much more difficult to address using official statistics. You can find out that in places where unemployment was higher, support for the National Socialist Party was higher as well. Now, people had their theory about why, which was, because unemployed people were really pissed off with the government and wanted to vote for a radical alternative. But that theory, as we know, turned out to be wrong. But it's really difficult to think, especially in the case of voting, of a why that wouldn't involve some sort of individual level data. So it's tough. You could find more things about that district. You could find what proportion of people at that time were in agricultural labour, and you could find what proportion of people at that time, I don't know, I was going to say owned a car, but it was a bit early for that, owned a horse. You could find some sort of, whatever equivalent to the census was in 1930s Germany, you could find more and more information about those neighbourhoods. But I don't think you'd really get that close to understanding why they were voting in a certain way, because official statistics are a bit kind of abstract from political reality. They tend to be socio-economic, for example, which is of some use, and clearly unemployment was relevant in the case of the rise of the Nazis, but hard to really answer a question like that top one there. Now, if you come on to why are richer countries happier than poorer countries, well, that one is probably a bit easier to work with official statistics still. Because if this is GDP, and this is average happiness, the bar across the top means average, as we'll see at great length next term, then somebody could say, well, actually, let's canvass some suggestions. Why would richer countries be happier than poorer countries? What's nice about money? Can you be a bit more specific? What would be, what type of living standard? What?
A lot of money provided government in like social services.
Excellent. So let's call it social spending by the government. And that's a useful one because that's an official statistic. We'll know that from government economic records. Any other reasons why GDP would generate happiness?
Better wages?
Yeah, though it's kind of they're so similar, but I mean, no, you're right. I've been unnecessarily judgmental about that one. You're right. Higher average wages. And that's, again, something you can find out through official statistics. Anybody else want to make a suggestion?
Better national security.
Yeah. Now that's a good example for this purpose, as were those, because better national security is the kind of thing that we social scientists talk about. And then we'd have to say, well, how are we going to measure national security? Could it be some sort of measure which is collected by social scientists of the number of external threats to the borders in a given year or a given decade? Or are we just going to go the same route as this and choose a statistic like number of the proportion of or amount of government money spent on national security? We could do the equivalent of that. And we could even do both, because there's no harm in trying both. And then we would see that happiness went up. But we'd still be there going, well, how do we... This would still look a bit like a correlation. Because what you'd ideally like, in order to confirm the kind of hypothesis that you're coming up with, is something that really shows us why it is that spending on national security makes people happier. Because I'm a bit oblivious to the spending that goes on. Britain, as far as I imagine, spends vast sums on national security. But I'm not sure it makes me any happier. In fact, they go on about it so much, it probably makes me a bit more worried and less happy. So if I would want to know what is the causal path along which government doing its stuff and reporting its statistics translates into something as kind of remote from that as individual happiness. And this is kind of the point I'm making here, which is that we can add in more and more aggregate level official statistics variables, and we can definitely get closer. These contributions have helped us to get closer to understanding how GDP would translate into happiness. And this one I see as a pretty strong link. This one too, though really what we've got missing in here is something like, and therefore sense of stability in the population. Somewhere in here there are attitudinal variables, perceptions of real people that result from those aggregate level variables. And what we are here now is back at, unfortunately this is the signals around there. Oh, good. What I've been doing in a different way, can anybody see the cloth, by the way? No, the cloth to rub the board. No, thank you very much for... That's all right, we'll have the break. I will use a precious tissue, but you can probably tell from the sound of my voice that these are critical currency at the moment. What I'm going to draw is Coleman's Bathtub. Most of you will have drawn it in your heads already as soon as it came up on the board, I imagine. But you'll remember that that was at the aggregate level, or the macro as Coleman called it. We have our variables, and these are our GDP and our mean happiness. But it's difficult to explain why, for example, national security spending influences happiness unless we know, well, what does national security spending do to individuals' attitudes, and what might it do to individuals' behaviour even, or something along those lines. What is it that, how does this impact on individuals? How does it get noticed? What does it mean that people think instead? And then that would lead to the happiness. So one clear thing is sense of national security. The more that they spend on this, the less likely external aggressors are to have a go at you. That makes people feel more secure and perhaps reduces the amount that they have to spend on personal security or something like that, and so it goes to the dependent variable. Not a great example, I must admit, but the underlying principle hopefully is clear, that if we really want to know why an X influences a Y, especially if that Y is to do with human beings, we usually want some variables that are at the individual level, attitudes and perceptions that we can't get with official statistics. And if we don't know, if we just see that X seems to be correlated with Y, and seems to be correlated with Y controlling for a few other things, we have to do quite a lot of what I refer to as causal inference. As in, we're not really demonstrating that X causes Y, we're just saying, well, it kind of looks as if it probably does, and we can think of why it does. So we are inferring that X causes Y rather than showing it. And you'll recall that internal validity of research is all about how confident are we that in the causal conclusions that we draw. So aggregate level official statistics tend to be a bit weaker on internal validity because they cannot supply those key variables about the way that X translates into Y that builds a detailed causal picture. And that, as the eagle-eyed or eagle-brained among you will have spotted, is where surveys are going to come in, as they will after the break, which will begin now and end at 6 minutes past 2. Okay, can you resume your conventional seating? And we'll get on with it. So, as discussed previously, like within immediate short-term memory, one issue with official statistics is their internal validity problem, that we don't often get to see how and why these aggregate level government collected statistics are related to each other. We can get to see that government collected statistic A is correlated with government statistic B, but quite why, it can be a bit tough to see. As always, if you want to know for sure whether X causes Y, you need to control for prior variables that might explain that relationship, and you ideally need to include intervening variables, as discussed there, which explain how X influences Y. Or, if it's people at the end of all this, you can ask them. If you want to know why people think something, or why they do it, well, you might think, well, you just ask them directly. Now, surveys have some potential to do both of those. Doubly annoying people coming in late now because the door has taken to making an offensively high-pitched noise, as we will now see again. Bloody hell, you were late for the first bit. Were we not on film, I would now ask you what you did during the break in some detail to get some kind of handle on how justifiable it was. I have my suspicions. Anyway, now we saw in previous sessions that there are, especially when focusing on qualitative methods, qualitative is the obvious route to this. If you want to know why somebody thinks something, why they do something, well, you ask them. Except that we did this, didn't we, where actually if you ask people why they did stuff, they often don't really know that much why they behave in a certain way. Certainly if you ask them why they didn't go and vote, they say something like, oh, I was very busy, rather than, oh, because I'm not that bothered, because they think that that's not a socially desirable answer. So surveys are kind of like halfway between official statistics and qualitative methods. Because, as we'll see in this and later sessions, surveys don't really go in much for asking people why they do stuff. They're still based on correlations, as in we ask them what they think about X and we ask them what they think about Y, and if those two are correlated, we say, right, X is likely to cause Y. So it's still kind of indirect, and it still has external validity because surveys are designed, as we know, to be based on samples, and those samples are designed to be representative of the population so that you can assume that what you got in that survey would be true of the population. And I know the words validity and reliability fly around all the time, especially validity, and you need to kind of keep remembering that there's internal and external validity, which is to do with the research, and then there's validity and reliability, which is to do with the measure. But external validity, you'll recall, is would the result we got from this research generalise to other contexts and populations? And surveys tend to score pretty well on that because they're designed on samples, which, okay, they might be a little bit different, as we saw in the opinion polls graph, but they're usually pretty representative. But they take us some way towards qualitative methods because rather than just relying on, oh, GDP did this, national security did that, and happiness did that, we can start to fill in with surveys the kind of attitudes and perceptions that might explain how and why that happened. So what is a survey? Well, it hardly needs dwelling on because everybody knows exactly what a survey is. Bryman, the kind of semi-textbook for this part of the course, has his definitions. People tend to use the words survey and questionnaire, interchangeably often. But really, survey means the whole shebang, including who you ask and when you ask and all that kind of stuff. And the questionnaire is the stuff that they answer. The other thing to highlight about surveys really is that they are a big workhorse for political research. And we started off with you either use official statistics, the aggregate level from the government, or you do a survey. Now that's an exaggeration because there are qualitative methods and there are experiments, but individual level research about individual people and their behaviour and attitudes is dominated by the survey. Sometimes it's surveys that governments do, or sometimes it's surveys that other researchers do. Sometimes they're done every year, sometimes they're just done because people think, oh, I need a survey on that. They tend to be available to us anyway, and they tend to have these three key advantages. Number one, unlike official statistics, we get individual level data. So we can see within a country, say, whether people who are more this are more that. You can usually, the length of a survey depends on the amount of money you've got and the amount of patience the survey respondent has, but you can usually run a survey, let's say it's face-to-face, for about 40 minutes before anybody starts objecting violently, and there's a lot of questions that you can ask in 40 minutes. So you can get a hell of a lot of variables. And, of course, we get to design the survey, at least unless it's a government-established one. So if you do your own ad hoc survey, you can ask exactly the questions you want, and then in that sense you are defining the variables exactly as you want to define them, rather than relying on whatever the government's interested in. And what do I mean by the lots of variables? Well, I mean the full causal model. And here you've got it set out in these kind of terms, but what I mean when I say a causal model, I'll do it in red rather than bothering to rub anything out, is, let's say that the final thing here is B for behaviour. Why do people behave as they do? A question that's frequently on your lips, no doubt. Well, it used to be in the old days that, and I need to update this slide really, that people thought it started off with their demographic characteristics like their age and sex. Actually, increasing research now thinks that there's quite a pronounced genetic component to political attitudes and behaviour. In particular, there's a lot of research showing that, for example, some people's skin reacts more violently to fear. If you show people a picture of a spider, they're sitting there doing your nice little internet survey, and you suddenly flash up a terrifying photograph of a spider. and you're measuring their skin conductance as it's known. Some people react more violently than others, and that's genetic. And those people tend to be more conservative. Conservatism is a response in that sense to fear. And so it does seem that political attitudes and behaviour have a genetic component over and above all the usual stuff like what age are you, what sex are you, what ethnicity you are, and so on. So let's include them for the sake of modernness. And your demographics affect your social location because it's easier for people of certain sexes or certain ethnicities to get into certain educational opportunities or social class. And then those people who are in certain social locations are more likely to have certain perceptions or beliefs, or more likely to have certain knowledge, let's say. I should be pursuing an example through here. So let's continue with conservatism. Let's treat the behaviour as voting for a Conservative Party. Well, there may be a genetic component that people who are more feel fear more pronouncedly are more likely to vote for Conservative options. It's more likely to give them conservative attitudes. I don't know why I scrambled all that in there. There's attitudes. Your demographic background, age might influence how likely you are to be conservative and vote for a Conservative Party. And your social location will tend to give you certain socioeconomic attitudes, let's say. People who are in better off social locations tend other things to remain the same, to have more conservative attitudes. And those attitudes are obviously likely to affect your vote, and there's probably arrows that I should have filled in here, but haven't. But you get the idea. And actually, these diagrams quite quickly start to look quite complicated. And the reason for that is that life is quite complicated. When you do your exam, you will be asked, indeed when you do your first assignment, you will be asked to draw a causal model like this of a particular x-y relationship, where there's y and x will be somewhere here, and you'll need to include prior and intervening variables. The point is, you can ask about pretty much anything in a survey. You can do the full causal model in a survey, and you look down that list, you won't find anything that you can't ask about in a survey. Genetics, unfortunately, don't fall into that category, which is probably why they've been ignored for about 50 years by researchers in this field, and I'm not sure how they will be incorporated, but if you assume that this isn't there for the moment, and we're just focusing on this, then you can do it in a survey. And your first assignment, the survey design assignment, when you've done the diagram, your job then is to translate that diagram into a questionnaire, including all of the variables that you've got here. Surveys in that sense are extremely versatile. And we have an example of this being able to define the variables as we want them from the Freedom House survey, measuring political rights. Because they don't just say to their raters, their local experts, oh, how democratic do you think the place is? They tell them what they think democracy means, what Freedom House deems that democracy means, and that very clearly directs those experts. And this is good news validity-wise, the validity of measurement, because validity is, are we measuring what we're supposed to measure? And the more that we can tailor that definition, especially if we're not relying on government definitions but imposing our own, the more valid the stuff that we collect. I'm peering at the clock because it's just, usually when I look at the clock, it's about 15 minutes further on than what I expect and want it to be. Oh, I must be just going quick, this bit. Doubtless you feel differently, but from my point of view, we're rattling through. And note that, let's say we say, well, I'm not sure that Freedom House is right, for example, to include all this nonsense about human rights in its measure of democracy, then no problem. We just remove that from the calculations based on their survey data. So, provided that enough of the right questions are asked, it's not that you need to use everything that somebody else has included in a survey. As long as enough is there, then no great problem. And here is their very clear instruction to people about what these things that the raters are rating the countries on actually mean. So they don't just say rate this place on political pluralism and participation, because it would be difficult to know exactly what that meant. They're more specific. Do other people have the right to organise in different parties or other groupings? And does the system allow for these to get better or worse without any calamities? So, validity-wise, when it comes to the designing the questions exactly as we want them, surveys score pretty well. So far, so good for validity. What about reliability? That is, do surveys generate data that are kind of not, they don't have lots of random error in? Would we, in a hypothetical world, do the same survey and get the same result? And we already began to discuss this last time when we were talking about the happiness scales and agreeing, I hope, that the happiness scale from 0 to 100 was pretty unreliable because, no, you probably wouldn't get the same result time and time again because very often somebody in exactly the same state of mind would say, I'm 72 one time and I'm 76 the next. No real change in their happiness, but the measure is unreliable because people can't tell that many differences. So we already have in the back of our minds one reason for doubt about the reliability of survey data, but there are some reasons for optimism. And they revolve around the kind of scientificness of survey measurement. Surveys, although it's a human interaction, at least there's one human involved, even if it's like an internet or a self-completion survey, you're attempting to kind of standardise as far as possible. So you don't just, it's not like a qualitative interview when you just ask a few questions and it could be in any order. You try to, well, you definitely keep exactly the same questions, asked with exactly the same wording in exactly the same order to all of the respondents. The idea being that that eliminates some sort of random error. You wouldn't want some random error just because, oh, the interviewer was different one time. So you want the interviewer to stay neutral as well. And it's actually quite a difficult skill if you think about this. I used to observe some interviewers in a previous job. And you ask somebody some horrendous question like, do you think that immigrants should all be sent back to where they come from? And the nasty man in the back room, and you're sitting in their house, so it's a bit weird anyway, and they will say, yes, I strongly agree with that. And you have to go, okay, strongly agree, in a studiedly neutral way. You can't say, seriously? You have to be resolutely neutral, all with a view to kind of removing the human side of it and making it as neutral and scientific and robotic as you can. And the other key hallmark of most survey data is that it's ticking boxes, which is a robotic kind of way of doing things. You don't ask people that, you don't say to somebody, "Well, tell me your views on immigration," and then go like that. You give them these statements and give them the boxes, and all they can do is tick one of those boxes, and in other words, you are going to reduce their opinion to a score out of 5 or whatever it might be. All of which is good news for reliability. It means you don't get very subtle or nuanced impressions of people's attitudes, but by God, it's reliable. Because if they strongly disagree with it, they're probably going to strongly disagree with it next time, and as long as you can tick the right box, and these days it's usually done by computers anyway, so as long as you press the right button when they say strongly disagree, the job's a good one. Apologies, by the way, to anybody who's very anti-immigration, because my views will seem very biased to you. Typical, Guardian-toting liberal I am, I'm afraid. Now, on to the doubts about reliability. Well, we'll do these in reverse order, because we've already seen a bit this second one. This is this varying interpretations of the response scale. Back to the Freedom House website, I went and found this. And it all starts off quite tediously. It's based on all these questions, blah, 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 blah. And then it says, scores are awarded to each of these questions on a scale of 0 to 4, where a score of 0 represents the smallest degree, well, not difficult to work that out, and 4 represents the greatest degree of rights and liberties present. What they don't do is set out for each of these categories, what does 1 mean, what does 2 mean, what does 3 mean, what does 4 mean. They tell you what it is that you're grading, and we saw it on the last one. Do political parties and groupings have a right to blah, 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 blah. So you know what you're judging them on, and you know that you've got a score from 0 to 4, but you're not told exactly what each of these things mean. And all of this might remind you of, it reminds me, of the departmental marking criteria, where we tell you that above 70 is a first, and 60 to 70 is a 2-1, and so on. And then you say, well, what does any of this mean? And then we give you these kind of strange phrases like 70 means that the candidate has shown an excellent knowledge of this and referenced adequately and blah, 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 and analytical strength and all these phrases that I barely know what they mean, and I presume you're a bit hazy as well. And in practice, what we do is we read 10 essays, we go, this was the best. These two were about similar, not a million miles off. This one, oh dear, and all points in between. And then we have a vague sense that the best one should get about 80 and the worst one should get about, it used to be 30, but it's now 40 to keep people paying the fees, and so on and so on. And it's not difficult to see how a bit of unreliability will creep into this, because it's not exact. It's not that we know exactly what a 69 looks like or a 66 looks like. It's just impressionistic. Now, my guess is it's pretty reliable. I think if I sat down and did the same marking again after, let's suppose I was involved in a chemical accident and lapsed into a coma, so lost all memory of the marks I'd given first time around, and then just did them all again, I reckon I'd give pretty similar marks. But I'm talking about like kind of plus or minus 2 either side, I think. Whether it's reliable across markers, that's a whole nother ball game. But the point I'm making is that when you don't really know exactly where the boundaries are, you can expect a certain degree of unreliability. Now, you can gain reliability, as we saw with happiness, by reducing the number of points. By getting these people to rate the countries on a scale of 0 to 4, they will boost reliability because it's unlikely, I mean, you're never going to be more than 1 point out. And these categories are quite wide if you think of North Korea. Apologies again to anybody who's a fan of North Korea because I'm being a bit biased against them. I'll try and think of some other despotic regime for next week's criticism. And then 4, we can think of some, it'll be Scandinavia that's best as usual. And then so there's a lot of countries. It's not going to be that difficult to guess where a country would be, and most people would probably agree when you've only got 5 categories. If there were 100 categories, there'd be a lot more unreliability. But then is 4 or 5 the right number? Maybe the average expert in a country can distinguish 7 or maybe 9 or 10 types of or levels of these things. Very hard to say for sure. So we are familiar with one source of unreliability. That surveys are full of scales, whether it's numbered points or whether it's, well, what makes me a kind of agree rather than a strongly agree. Still a source of unreliability. And then, of course, there's the interpretation of the question, which also will vary somewhat at random across people. If you ask a question like, do you think that this country spends too much on welfare? Chances are most people will be thinking about what they see as the undeserving welfare recipients, unemployed, well, people who say they're unemployed but needn't be or whatever. But then other people will have in mind pensions, and nobody apparently seems to, apart from me, seems to think that pension spending should be reduced. So any question pretty much will have some kind of term in it, if it's going to be remotely interesting, like welfare, that is open to different interpretations. And that is a source of unreliability, because you're going to have random errors, random differences between people that are not due to their differing attitudes on a given question, they're due to differing interpretations of what the question is actually asking. Now, in the case of Freedom House, most people have got a pretty good idea what they're talking about when they say, is there a significant opposition vote and a realistic possibility for the opposition to increase its support? But what it means, what significant means, I don't know. What realistic means, questionable. So the way that those words are interpreted and the way that they are then applied to the response scale is a source of unreliability in this kind of data. Now on to validity. Remember, I did validity in terms of, I'll say remember, I can't. Oh yeah, we said that on the one hand surveys score pretty well in validity because at least the questions are defined in the way we want to define them. We've already seen that there may be trouble conveying that meaning to the respondents. Now we're on to the separate question of whether the actual answers that we get from people in surveys genuinely represent their opinions and behaviours. And there are again grounds for optimism, one of which revolves around another aspect of the scienceness of surveys is their anonymity and confidentiality. You know, you get told the answers to this will go no further than the researchers, we're not going to ask your name, all of that kind of stuff. And that helps to make people more honest. And as we'll see in week 11, and then you'll deploy for your assignment, there are some very clear rules for making questions clearer in a way that will then maximise validity. There are, however, as we'll also see in week 11, which incidentally is my favourite week of the term, a lot of reasons to doubt the validity of people's survey responses. And I'm not going to talk about those now because we'll talk about them so much more detail in week 11. Suffice it to say that there are a lot of reasons to worry about whether what you get as survey responses truly reflect what people think and do. And sometimes it's to do with lying, but a bit like with governments, it's not mostly to do with that. It's not deliberate manipulation, it's other problems. Now, moving from the internal validity, no, not the internal validity, moving from the validity of measurement, that is, are the individual questions measuring what we want to measure, we now move to the external validity question, which applies to the research, which is how generalisable are the results of a piece of survey research to the population that we are after. And this, there are reasons for serious optimism, and they lie in the magic of sampling, as to be set out next time. It is, in some level, unbelievable that a sample of 1,000 Chinese people is a pretty accurate representation of the views of it's not 2 billion, is it? 1 point something billion Chinese people. I find that, magical's too strong a word, but I find that weirdly impressive. And the fact that we can give people the same, you can do a survey in Britain and then somebody translates it to Flemish and then somebody translates it back to check that their translation to Flemish translates back into English appropriately. And when everybody's agreed, you go give your, a faint stammer there, you're giving exactly the same questions to the Flemish respondents as you gave to the British respondents. And that kind of standardisation encourages faith that you can compare these responses across Britain and Flanders in Belgium, and differences won't be to do with the fact you messed up the research, but genuine differences between the people in those countries. As we'll see next week, there are some reasons for doubt, but don't be fooled by the length of this list here, because although all of those 4 things, which will be explained in great detail next week, are reasons to place some doubt, what they tend to do is put a bit of random error around what is still fundamentally a pretty externally valid way of going about doing things. Sampling is good, in short. Now, so surveys, to summarise briefly so far, actually I won't summarise briefly so far because there'll be a summary slide in a short while. So far I've done the kind of taking the surveys on their own terms, are they any good? Some people have a broader set of criticisms that they make of surveys, all of which have some basis to them. The first one is to kind of do the lack of context. Surveys are a deliberately atomised thing. In fact, if you go to interview somebody in their home and you sit at one end of the kitchen table and they sit at the other, if their husband is slumped in an armchair in the corner, you have to ask that person to leave the room. The suspicion being that that will pollute the science-y, one-on-one neutrality of the survey context. Now, that possibly does mean that the person you're interviewing will give different views on, for example, the gender roles within the family than they would have done had their oppressive husband been still sitting there in the armchair. But, on the other hand, that woman is in a certain family context, and it's arguable whether her views as expressed in the artificial neutrality of a one-on-one survey interview better reflect her attitudes and values than those which she would express in her normal contexts. We are people, we are social animals in social contexts, and if you abstract us from those contexts to do a survey, it's questionable whether you get valid impressions of how we will operate in the real world. Surveys, to use a more technical term, atomise individuals. I like it when I say technical, everybody picks their pen up for the first time in 25 minutes. And some people even wrote it down, so bravo. Then there's a lack of context in terms of time. They tend to go together, these kind of space and time things. It's very expensive to do panel surveys, which are what you really want. What we really want to do is survey the same people year after year after year. That's how you find out whether, for example, being beaten as a child makes you into a beater of your own children or somebody more likely to support the death penalty or whatever it is. But it's incredibly expensive to do this kind of thing. The most expensive survey by far in Britain, other than the census, is called now Understanding Society, and it's based in the, I can't remember what it stands for, ISA, Institute of Social and Economic Research, which is at Essex. And they do go to the same people, and they've been doing it for years and years and years. But people are dying all the time, and the sample's dwindling, and there's only about 800 people, I think, left now who've been doing it for years. Incredibly expensive. Most of the time, we just do a survey at a certain point in time, and we rely on correlations to stand in for causality. So we just ask somebody, were you beaten as a child, and what do you think about the death penalty? And if the two correlate, we think, oh yeah, it must have been that they were beaten as a child caused that. And it's not clear at all. It's possible that those two are correlated but not causally related. We'll never be absolutely sure. Cross-sectional, you'll remember that from when we did the, nobody nodded, but you will remember that from when we did the week on, I can't remember what it was called now, but the week when we were looking at, there was a big table at the end, you'll remember that, where it was, what do you call it if you're, thank you for nodding. That's enough for me. That's the validation I'm after, one person. And then you'll also recall, now we're on a roll, the discussion of the scientificness of politics and the objection of the ideology and discourse people who say that actually all of this research is done within the context of these very deep hidden forces, these hidden ideological forces, usually involved, associated somehow with evil capitalism. And actually what we do and what we think is shaped by these much deeper meanings and values that we can't access, and all of the survey research kind of goes on within that context but fails to grasp it. We're failing to grasp what really drives the political world. And as usual, we have to kind of confess that may be true, but there's no way we'll ever know whether it's true or not. And surveys won't measure them, that's for sure, but what can you do? So, there's the summary slide which I promised. I won't read it out because it's there for you to remember. The bad news is the lecture is not over, because we're going to end with an example of a research question, quite a simple one, addressed by both official statistics and surveys. I'll present those two alternatives. You can ask questions if there's a bit of time left, and then we'll start the next week's lecture with which you think is more accurate. And that research question is straightforwardly, how many civilians died as a result of the Iraq war? Which you're presumably old enough to know exactly what I'm talking about with the Iraq war, I'm guessing. I mean, it's still going on, presumably, so. Question?
600,000.
Well, hold on. We'll get to that. But that's a not unreasonable supposition based on the, as we'll see. Good knowledge. So, first source of data, first attempt to estimate the Iraqi civilian dead was the Iraq Body Count Project. So called because some American general, who'd presumably been watching too much television, said when asked about this, we don't do, I won't do the accent, he said, we don't do body counts. Which struck some people as a bit callous, including this group of academics and activists who set up the Iraq Body Count Project, a human security project which is supposed to maintain a database of media-reported civilian deaths. And as we'll see, this is all based around the first 2 or 3 years of the war. They haven't stopped, but the particular example I'll give will be from that. So it's a group of kind of, well-meaning people working for NGOs or activist groups or universities trying to estimate the deaths. And the key point is they're basing it on the documented deaths, as in there has to be some kind of documentary evidence for these things to go into their count. And they had 2 components to this. They tried to work out, which wasn't necessarily very easy, but in addition to the kind of obvious ones where a bomb explodes at a wedding and a number of civilians die, they also had cases where, in a particular town, the war had resulted in a complete vacuum of power and people were running amok in a lawless way, and they tried to estimate how many more deaths there were as a result of this than there would have been had there been no war, which wasn't all that easy, but as we'll see later, it probably isn't the most crucial detail. They weren't counting the deaths of non-civilians, because this is a civilian death estimate. Now, documented deaths, what does that mean? Well, there are a number of potential sources of data, and they define documented pretty broadly. It doesn't need to be, in that sense, absolutely official statistics. They also included media reports. Official statistics were also included, records of deaths from mortuaries or hospitals, other official sources. NGO reports counted, as well as media reports, and even eyewitness statements, provided accessible, did count as documented deaths. The crucial point was, no one of those alone was enough. They needed to have a death, for want of a nicer way of putting it, kind of corroborated. So something would go into their database, for example, if a media reported that 3 people died in a such and such, and they could then go to the local hospital and find records that those people had died. Or, for example, the police reported 1 person died in a such and such, and they had an eyewitness who said, yes, he's right, they did. Now, unfortunately, because not all of the people involved in this project spoke the local language, they were reduced to English-speaking sources. The documents didn't have to be in English for obvious reasons, but they needed some kind of English-speaking corroboration, which seems a bit lame to me, but they did. And very often, what would happen is that they would hear some sort of report, whether eyewitness or media, that, let's say, 7 people died in a certain thing. And try as they might, they could only find 4 official records they could only find 4 deaths. In other words, for each incident, they would often end up with a maximum number of people dead or a minimum number. Let's say the 2 reports were not exactly in line, which means that the total estimate of deaths you get is a range rather than an exact figure. And that range, in October 2006, was between 43,000 and 48,000. Getting very excited in the other room. Now, the Iraq body count people say, we have always been very explicit, quite explicit they say, sorry, I shouldn't put words into their mouth, that our own total is certain to be an underestimate of the true position because of gaps in reporting or recording, which will remind us of the official statistics thing about coverage. You know, there are things that you miss that official statistics miss. There will be deaths that lots of people are saying happened, but you couldn't find the sources, the official documents or whatever. How much of an underestimate remains to be seen. So it seems unlikely that the actual number is less than that, let's put it that way, and probably somewhat more. Whether it's as much more as the initial guess of 600,000, we shall see in a short while, or at least we'll discuss in a short while. The second source of data that we're going to be comparing is a survey that was published in the medical journal The Lancet, or rather the results of that survey. And this was a household survey in Iraq, again organised by academics, they're again everywhere, organised by academics in the US but administered by academics in Iraq. And the way this worked was people were asked basically to record, rather morbid but necessarily so I guess, process where if I'm the interviewee, I am asked, right, tell us about who's died in the last, 10 years in your household. And you say, well, back in May 97 there was grandma and so on and so on. And you fill in all the deaths that have happened. And that gives, given that they know the starting point of the war, once all the results are in, the surveyors can compare the death rates before the war and the death rates during the war and see how much those have gone up. Now the surveyors tell us that birth certificates should be death certificates, sorry, were usually provided, and I think when pressed on this in a later publication they said this about 80% of the time death certificates were provided. So what they're calculating here is the extra deaths, because you wouldn't expect there to be no deaths during the war. You'd expect deaths, whatever, even if there hadn't been any war. You basically expect the pre-war death rate to continue. You perhaps expect it very slightly to decline as the country, because death rates in most countries are going down anyway, but not so much, not so violently between 2003 and 2006 to affect things much. So the question is, how many extra deaths were there than what you would have expected? Do we have yeah, we do. Now, I'll talk a bit more about what all this means next time, because we haven't done sampling yet. What they didn't do was get a huge long list of everybody in Iraq and do a random sample of 1,000 households from that list. Because, well, for all sorts of reasons. Probably because one of them would have been in some horrendous war zone, and because it would have been extremely expensive because there'd probably be 1 mile away from anywhere, which would cost a fortune to get to. What they did was instead this kind of geographical cluster sampling, where what you do is you sample areas within a country, small areas, and then you kind of do the random bit within that. And this approach to sampling that they did. Let me just bring that. This late stage, I can't be bothered to mess about with. But now this is stuck in there. Bear with me while you read the sampling details. So, here is a map of Iraq, impressionistically speaking. Here is a region within Iraq, and there are 18 of those, and in, let's say, one of those regions, we have this particular cluster. That was sampled. This is a little area of a region in Iraq. Oh dear. Logistical nightmare, isn't it, this? And all in front of the cameras. So, let's now have a larger map of this cluster. And this will have its towns and streets and cities and all that. Let's say there's the biggest town. Now, within this cluster, here is a little town, and here is a map of that town with its main street. So they've randomly sampled a main street, and then they randomly sample a smaller street, a residential street that goes off that street. Can you guys actually see any of this? Or? And then they randomly sample. So there's a lot of randomness in there. And they randomly sample this street, and let's say they randomly sample this household. So these are the first people to be surveyed. This household, the lucky winner, is going to be interviewed and asked about the deaths. And then they move to the next household along, and so on until they've got 40 households in that cluster. That's how they did the sampling. Now clearly it's not the same as a pure random sample, as we'll see next time, but it has a fair bit of randomness in it. But all I'm going to tell you is how they did it. 47 clusters, 40 households, should have been 1,920? No, 1,880 households. But there were always, as usual, some missing households. You know, perhaps the guns started firing before they'd finished and they just got out. But they ended up with that many households with that many people. And they calculated that based on the pre-war death rates compared to the mid-war death rates, in those households, with that many people, there were 629 more deaths than there would have been had there been no war to rudely interrupt. So 12,801 people, 629 more deaths. What they then obviously have to do is multiply that by the ratio of the whole population of Iraq to the size of that sample to get how many more deaths there have been in Iraq. And what they come up with is 655,000. Now, I've rubbed it off now, or flipped it away, and I'm not even going to... Actually, was it the other side of this? No. The graph of the sampling has disappeared forever. So I'll have to draw a new one. Remember with the opinion polls, you had something like that. Because opinion polls use pretty random samples and are quite accurate. The people who did this survey recognised that the sampling's a little bit dodgy in some ways. And so actually, the graph for the sample, I'm going to get rid of this to make it a bit clearer, looks more like that. Their best guess of the number of Iraqi dead is 650-odd thousand. They recognise that there's quite a big chance that it's quite a lot less than that. There's also quite a big chance that it's quite a lot more of that. And we'll see in later sessions what it means by a 95% confidence interval. But for our purposes, what it means is they're pretty damn sure that it's at least more than 392,000 and that it's at least less than 942,000. All of which means, as far as their survey is concerned, it's incredibly unlikely that it's 45,000, which is what the Iraq body count said it was. So there is violent disagreement, it's an unfortunate choice of words, between those two estimates. What I would like you to do between now and next week is to decide who you think's, if not right, then at least the most close to being right. And at the start of next session, we'll discuss why you think that and who's right in the context of sampling. Thanks.